All right, so we'll go ahead and get started. Possibly, we'll go ahead and get started. I need to figure out the format. So title your notes: rationalizing. Radicals. There are a couple rules with rationalizing radicals. So as mathematicians, you guys are all mathematicians, we never, never, never want to leave the denominator in a fraction with a radical. Do you remember what a radical is? A radical is when you have the square root or the cube root or whatever, right? So I always tell my kids it is bad math manners. Bad math manners to do so. So you can't have a square root or a radical in the denominator. Bad math manners. Is it mathematically correct? Yeah, it's mathematically correct. It's just bad. It's just bad form, so it's really hard to simplify. So I'm going to give you guys, before we even do that, I'm going to give you guys some rules for adding and subtracting. So and multiplying and dividing. So when we add and subtract radicals, so for instance, I'll do a little sub-example, number 1. If I have 2 plus the square root of 3 plus 4 square root of 3. I'll give you guys a couple seconds to write that. So I have 2 square root of 3 plus the 4 square root of 3. When you're adding or subtracting radicals, you can only add like radicals. So 2 square root of 3 plus 4 square root of 3 gives you 6 square root of 3. Does that make sense? So that would be my final answer. You keep the last guy the same. So what if I had 4 square root of 3 plus 7 square root of 2 plus 5 square root of 3 minus 4. All right, go ahead and write that one down. So for this guy here, the only common terms I have are these guys right here, the square root of 3's. And so what is 4 square root of 3 plus 5 square root of 3? 9 square root of 3. So that's the only thing I can simplify. I cannot add 7 square root of 2. He's just chilling on the end. And then your minus 4 is also chilling on the end. That would be my final answer. I cannot simplify that. Now let's talk about multiplying and dividing. Alright, so when we're multiplying this, that was example number 2. We'll do example number 3. So when we multiply or divide, so if I have 4 square root of 3 divided by, actually let's change that to 10. And then we have divided by square root of 5. Do it up. So when you have the square root of 10 divided by the square root of 5, here we can go ahead and divide them. So this would be square root of 10 divided by the square root of 5. What is the square root of 10 divided by the square root of 5? What is 10 divided by 5? 2. So the square root of 2, and then this becomes 4, chilling on the outside. That would be my final answer. So when we multiply, if I had the square root of 3 times 4 square root of 2. When we're multiplying, you can multiply these guys. So the square root of 3 times the square root of 2, do you know what that is? A square root of 6. And this 4 is still chilling on the outside. You always want to check that your radical is simplified right. So if I had the square root of 60, you would never leave your answer the square root of 60, right? How could I simplify the square root of 60? Yeah, 10 and 6, and then this would be 5 and 2, and this would be 3 and 2. So you always want to make sure you still have to simplify your radicals. So this would be what? 2, have a pair of 2, so 2 square root of 15. Does that make sense? So just remember those rules as well. So now let's get to the rationalizing. So the first example that I'm going to give you for rationalizing, so we'll call this example number 5. Example number 5. So if I give you something like this, 3 divided by the square root of 2. And so again, you can't have a radical in the denominator, right? So how you simplify a radical, guys, is you're going to multiply by itself. So what is the square root of 2? Square root of 2 on the bottom. But what you do to the bottom, you have to do to the top, because that's multiplying by a factor of 1, right? This over this doesn't change the value of it. So what is the square root of 2 times the square root of 2? The square root of 2 times the square root of 2 is the square root of 4. And what's the square root of 4? 2. So easy trick to remember, guys. If you're ever multiplying, this is your trick, something that's the same base underneath. So like if I have the square root of 2 times the square root of 2, you're going to get 2. If I have the square root of 5 times the square root of 5, you're going to get 5, because 5 times 5 is 25, and the square root of 25 is 5. And then up here, I can't multiply these because it's on the outside of the radical, so it'll be 3 square root of 2. So then I have 3 square root of 2 follows through, and then check if these numbers, because these are both real numbers, right, outside, check if you can cancel. I can't, so that's my final answer. So let me give you another example. So we'll call this example number 6. So if I have the square root of 3 over the square root of 5, right? This guy, what I'm going to do is I'm going to multiply by square root of 5 over the square root of 5. Because I can have a radical in the numerator, I just can't have it in the denominator. So in the numerator, you get square root of what? 15. And on the bottom, square root of 5 times the square root of 5 is 5. Can I break down 15, or is he good? Yeah, I can break him down, but it's 5 and 3, but those are both prime, so that doesn't do anything, right? So he's good. So that's my final answer. All right, let me give you another example. So we'll call this example number 7. So what happens if I give you 42 divided by the square root of 7? So I'm going to do the same thing. I'm going to multiply by the square root of 7 over the square root of 7. So on the top, I get 42 times the square root of 7. On the bottom, I get 7, yes? But can I simplify this? Yes. Yeah, 42 divided by 7 is what? 6. So my answer is 6 times the square root of 7. The only reason I can simplify is because everything's being multiplied, right? They're not attached. If it was adding or subtracting, it would be different, and I would have to do an iHeart math. Alright, example number 8. I'll give you another example. So what happens if I have something like this? 1 over 4, 1 divided by 4, square root of 2. Now, who's the bad guy? Who has the bad math manners, the 4 or the 2? The 2. So the 4 is okay to stay down there. I don't need him to move. Remember, these are being multiplied, so they're not attached. So I'm going to multiply the top and bottom by the square root of 2 over the square root of 2 only. Do y'all see that? So in the top, I get the square root of 2. On the bottom, I get the square root of 2 times the square root of 2 is 2, right? It's 4, which the square root of that is 2. But then this 4 is still chilling. I'm going to put this in parentheses, because now I have to do what with these two numbers? Multiply them, right? Don't write them next to each other, because then it's going to look like 42. So 4 times 2 is 8, and then that is my final answer. Alright, let's talk about if we get something a little weird. So what happens when we add or subtract on the bottom? So we have two examples left. So we'll call this example number 9. So if I have 1 over 3 plus the square root of an 11. Now this changes the ball game because there's a plus sign. There's two terms and there's a plus sign. And we can't just multiply by the square root of 11 because that's not going to cancel the radical out. What you have to do is you have to multiply by the conjugate. Like that. So conjugate. And what the conjugate is you change the sign in the middle of the binomial. And I'll show you why we do that, because it's going to cancel out. Now it's conjugate, not like Spanish class where you guys conjugate verbs. It's a little bit different. So what we're going to do is we're going to multiply by its conjugate. What is the conjugate of this? You're going to change the sign on the inside. So instead of 3 plus the square root of 11, it's going to be 3 minus the square root of 11. And what I do to the bottom, you do to the top. Right? So it's going to look like this. So this is its conjugate. Now in the numerator, you just have itself because it's this times 1. So it's 3 minus the square root of 11, yes? But on the bottom, it's this times that, right? It's two binomials being multiplied together. Do you guys remember what you do when you have two binomials and you multiply them together? You FOIL, yes. Super duper important because this is going to cancel out the radical, and I'll show you why. So first, 3 times 3 is, outer you get, be careful, negative 3 root 11, square root 11. Do y'all see that when you do the outer ones? And then the inside ones you get what? Positive 3 times the square root of 11. And then last you get the square root of 11. It's positive times a negative. What is a positive times a negative? Negative. And the square root of 11 times the square root of 11 is just 11. It's 121, and the square root of 121 is 11. What do you notice about the radicals now? They cancel. Those guys go away. So on the bottom, we're just left with real numbers. Do y'all see that? Just real numbers, which is nice. And that was our whole goal, was to get rid of the radical on the bottom. So let's simplify this a little bit further, right? 9 minus 11 gives me negative 2. But it's weird having a negative on the bottom. It's just kind of like, again, bad math manners. So this is what you can do. You can write your answer with a negative to the side, but you need to make sure you put this in parentheses. Right? You can write your answer like this. That would be totally okay. Or I can do what with that numerator, or that negative to the numerator? I can do what? What's another way I can simplify this with that negative? I can, distribute. So it would be negative 3 plus the square root of 11 over 2. I'm just showing you different ways how these are the same answer. But you never want to leave your answer like this, because again, those are the bad math manners. Having a radical in the denominator, or having a negative in the denominator. Those are both bad math manners. Alright, last one we're going to do. Let's see if you guys can try this on your own. This one's a little bit trickier. I got 2 minus the square root of 3 over 5 plus the square root of 2. So this one's a little bit trickier because now you got a FOIL on top and bottom. Do y'all see that? So give you guys a couple minutes to work on this one. And then y'all try this one on your own.
Conjugate only when you subtract it?
Conjugate just means opposite signs. So you're now going to multiply top and bottom by what? 5 minus the square root of 2, right? Because the numerator can have a radical, it's just the denominator. So you're basically going to have to FOIL top and bottom. How are we doing? You're like, I'm not sure if it's right. Alright, so let's see how you guys did. So I'm going to multiply by the conjugate of the bottom. So 5 minus the square root of 2. Right, so I'm going to go ahead and FOIL top and bottom. So first you got on the numerator 10. Outer you get negative 2 square root of 2. Inner you get negative 5 square root of 3. And then last you get a negative times a negative is a positive. The square root of 3 times the square root of 2 is the square root of 6. Right? And on the bottom, I'm going to go ahead and FOIL. Now what's a trick I can do for FOIL? If I know the inner and the outer are going to cancel. Which ones can I just do? F and L. I always tell my kids, just Florida it. Just Florida. FL. Florida. We're almost to Christmas. We're almost to summer. So I really just have to multiply the first and the last because I know the outer and the inner are going to cancel out because I'm multiplying by the conjugate. So 5 times 5 is, and then positive times a negative is a negative. Square root of 2 times the square root of 2 is 2. So then my final answer, can I smush any of these or combine like terms? No, so that all stays in the numerator. Do y'all see that? Which I know it looks kind of ugly. You always want to make sure though that if you can simplify your radical, and we can't. And then 25 minus 2 is 23. Anybody get this right? Yeah, 2 people. Woohoo! Alright, so we'll go ahead and stop.